Alright, welcome back everybody. This, I imagine, will be the last video of new material for the semester. That makes me a little sad. I wish I had more time with y'all, but you'll probably be watching the rest of this video with a smile on your face, because it's the last one. In any case, let's go ahead and get into it. So, in the last part of this video, or in the last part of this section, before this one, we talked about Guess and Gary, Coin Flip Caroline, and Sam Who Studies. They're taking an 8-question multiple choice test with 5 answer choices per question, and we were able to calculate how many questions we would expect each of them to get correct with a certain standard deviation. So Guess and Gary is only expected to get 1.6 of the 8 questions right on average, with a standard deviation of 1.13. Coin Flip Caroline has a mean of 4, exactly half of 8, with a standard deviation of 1.41. And Sam Who Studies is expected to get 7.2 questions correct, with a standard deviation of 0.85. So, we might have an idea of how many questions we expect each of them to get, but what would be a weird or unusual result for any of these students? I mean, obviously, Guess and Gary getting all 8 questions right would be unusual. But what's the cutoff value? Would it be unusual for him to get 6 questions right? 4 questions right? Where's that line? Okay, and we could do the same type of thing for Coin Flip Caroline or Sam Who Studies. We already determined Sam Who Studies, she gets 8 questions right a lot. But what's the low end? How few would she need to get right for it to be unusually low for her? Luckily for us, there is a way to calculate how something is unusual or not. And that's this. So a value for the number of successes is considered unusual if it is either less than the mean minus 2 standard deviations. So more than 2 standard deviations below the mean, or if it's greater than the mean plus 2 standard deviations. So if it's more than 2 standard deviations above the mean. So what we're saying here is, essentially anything within 2 standard deviations of the mean is okay, somewhat expected. But once you get more than 2 standard deviations away from the mean on either side, that's a pretty unusual result. So, for each of our students here, let's calculate those boundaries of what is considered unusual. Let's calculate the mean minus 2 standard deviations for everyone and the mean plus 2 standard deviations for everyone. So, Guessing Gary first. His mean is 1.6. So we want to subtract 2 standard deviations from that. So 1.6 minus 2 times 1.13. That's going to be, I'm just going to get my notes out here so I don't have to calculate it myself, negative 0.66. This calculation is correct. And what it means is, we expect that it would be unusual for Guess and Gary to get less than negative 0.66 questions right on this test. Does that seem reasonable? Well, yeah, that would be unusual. Okay. What this number is really telling us in the context of our situation here is that we wouldn't even be surprised if Guess and Gary got 0 questions right. That is within 2 standard deviations of the mean. So even if you got 0, that's not super unlikely. All right. So let's figure out his upper bound. How unusual is unusual for Guess and Gary on the high end? Well, it'll be the same calculation as this one, except your negative sign becomes positive. So 1.6 plus 2 times 1.13, that's going to be 3.86. So this allows us to figure out, oh, okay, anything over this is unusual for him. So if he gets 4 questions right, that's kind of unusual. The way a teacher would really use this information is to say, guessing Gary took this test and he got 7 questions right out of 8. What does that tell us about guessing Gary? Probably cheated. This is a reason not to cheat on any test or quiz given by a statistics teacher, especially once you have a track record. If you're a guessing Gary and you do really, really well on a test that's way above this value, that's essentially proof that you cheated. Okay, so that's one more reason not to be guessing Gary. Okay, maybe if you were Sam Who Studies and you got a really good grade, I wouldn't know any better. But guessing Gary is only expected to get up to this many before it's considered unusual. So, sorry guessing Gary. You're on notice. All right, let's find these for coin flip Caroline. So the mean minus 2 standard deviations. Her mean is 4, and her standard deviation is 1.41. Oops, I forgot to multiply that by 2. That would only be the mean minus 1 standard deviation. Minus 2 times 1.41. Now, in the last video, we said that coin flip Caroline's standard deviation was bigger than the other 2 students. So she's got more variability. So when we calculate these values for her, it should be a wider range than, say, for guessing Gary. So 4 minus 2 times 1.41 gives us 1.18. Which might seem a little low for her. She's expected to get half the questions right. But since she's guessing 50-50 on every question, it's actually not unusual for her only to get 2 questions right on a test of 8. Now, only getting 1 would be less than this, and that is unusual. But even something as low as 2 out of 8, not unusually low for her, because she's got a lot of variability there. On the high end, mean plus 2 standard deviations. That's going to be 6.82. So again, that seems pretty high. Even getting 6 out of 8 is not unusually high for her. Okay, it's definitely higher than her mean, but it's not unusually high. But once you start getting into 7 or 8 questions right out of 8, that is a little unusually high for her. 6.82 is that limit. All right, let's do the same thing for Sam Who Studies. I'm actually going to calculate this one first because I can. We know that we're not surprised to see her get 8 questions right, but I'm wondering what 2 standard deviations above her mean is. Her mean is 7.2, and we would be adding 2 standard deviations. So that'd be adding 1.7. This is 8.9? Yeah. So it would only be unusual for coin flip Caroline to get more than 8.9 questions right out of 8. I don't want you to do a calculation like this and say that it's meaningless. This is telling us something. It says we're not surprised even if she gets all 8 questions right. Okay, so if this number happens to be out of the realm of possibility, that just means we're not surprised on the high end about any result. Okay? But the interesting calculation for Sam Who Studies is this one. How low would she have to score for it to be considered unusual for her? Well, we're going to subtract instead of add. So 7.2 minus 2 times 0.85. We're subtracting 1.7, is that 5.5? Yes, 5.50. Okay, so if Sam has a bad day and only gets 6 right, that's not an unusually bad result for her. But anything 5 or lower, I mean, it can happen. It is possible, but it is definitely unusually low for her. If she only got like 2 or 3 or something, might pull her aside after you grade that test and be like, yo, Sam, what's up? That's not like you. Okay? So, as long as we know the mean and standard deviation of a random variable, how many questions Guessing Gary gets right, or Coin Flip Caroline, or Sam New Studies, we can determine what values are unusual or not. So the way that might manifest itself for you on like a homework assignment or a test or something like that might be like, okay, I give you a random variable and its mean and standard deviation and ask you, is it unusual to get 9 successes in 20 trials? And by doing this calculation, you can determine whether that number of successes is within this range or whether it's outside of it. Okay? So that's what you can expect. So let us go forth, and in your notes it has a couple of problems from the textbook. I figured since we're not in class, you should at least see something like what your homework will look like. So page 241, number 23, if you've got your textbook on you, go ahead, pause the video, grab it, come back when you've got it, and we'll go through it. If not, just follow along. Okay, so on number 23, does crime pay? Okay, so the FBI released a survey that shows for about 80% of all property crimes, the criminals are never found and the case is never solved. For about 80% of all property crimes, the criminals are never found and the case is never solved. To anyone watching this, I am not endorsing property crime. Okay, I'm just stating statistical facts. There's a 20% chance you will get caught, so don't do it. Don't commit property crimes. Yeah, okay, so I might want to write that down. 80% chance not caught. My apologies if you're hearing some background noise. It started storming about 10 minutes ago, and it's loud. Sorry. Suppose a neighborhood district in a large city suffers repeated property crimes, not always perpetrated by the same criminals. The reason they're putting that sentence in there is to suggest that these crimes are independent of each other. Okay? If we want to be using the binomial model and all the things we can do with it, we need a binomial experiment, and one of those foundations is that each individual trial is independent. If we assume the same people are doing all these crimes, they're not independent. So let's assume that each one is independent of the rest. The police are investigating 6 property crime cases in the district. Investigating 6 cases. Okay, so part A. What is the probability that none of the crimes will ever be solved? What is the probability that none of the crimes will ever be solved? So it's important to be able to take this problem and realize that you do have a binomial experiment here. Okay? And you can check the conditions if you want. It's not necessary for this problem. You've got 2 outcomes, success or failure. Either the people are caught or they're not. We already suggested each property crime is independent. We are assuming that. We also know that the probability of getting caught is the same for each property crime. 80% chance you don't get caught, which means there's a 20% chance that you do. So if we want to know the probability that none of the crimes will ever be solved, we need to determine what that means in terms of this. Okay, I want to be able to write that sentence as the probability that the number of successes is something. Either equal to something, less than something, greater than something. Okay, so I need to determine what a success is, because X stands for the number of successes. Is it a success if they're not caught, or is it a success if they are caught? I think it's reasonable to suggest that X, the number of successes, is that they are caught. So I'm going to write success equals caught. Okay. So we want the number of successes, the number of people that are caught, to be what in this problem? That none of them are ever solved. So that's 0. Okay, we want the number of successes, the number of people caught or solved is 0. Okay. So in order to calculate this, we need to think about what n and p are. Okay, those are the parameters that we need. So n here is the number of trials. One trial would be one property crime being committed. So we are looking at how many of those crimes? 6. So n here is 6. And p is the probability of success. So that is the probability that the people are caught, or that the case is solved. What is p? If you said 0.8, that's the probability that they're not caught. But we're saying the success is that they are. So that's going to be the other 20%. P is 0.2 here. P is 0.2. So to solve this, you could use the binomial probability formula. You could do that. You could do, okay, we want to know number of combinations, 6 choose 0, right? This is n. This is the number of successes we're interested in, times the probability of success to the number of successes, times the probability of failure to the number of failures. You could calculate it that way. But based on the previous several videos in this section, we know that there's a faster way. Using the calculator. This is a binomial PDF problem because we want to know that the number of successes is exactly 0. That's a PDF problem. Where n is 6, p is 0.2, and the number of successes we're interested in is 0. Okay, so all we need to do is use our calculator and type that in. Or you could calculate this out. I think it would be much easier to use this. So whether you've got a physical calculator or you're using the online one, binomial PDF 6.20. Let's make sure I got the same thing last time. Yes, 0.262. Okay. So there's a 26.2% chance that none of those 6 cases get solved. All right. Part B. What's the probability that at least one crime will be solved? The probability that at least one crime will be solved. Okay. I can at least write that. Okay. Anytime I'm asked for the probability of anything binomial, we can at least write that. The question is what goes in here. That at least one. At least one greater than or equal to 1. All right. So what the probability that it's greater than or equal to 1. Our goal is to be able to use the calculator, either binomial PDF or binomial CDF. Which one are we going to be using for this? PDF or CDF? Well, actually, you could use either one. But if you're thinking of using CDF because this is not an equal sign, that's the way I want you to think. We need to think, okay, binomial CDF counts from 0 up. This is counting from 1 up. Binomial CDF cannot deal with a greater than or equal to sign. It needs to be less than or equal to. So that means we need to use the complement rule. And that means we need to change that to a less than or equal to sign. Okay. And we need to write here the opposite of this. So this is saying that the number of cases that's solved is anything from 1 up. So 1, 2, 3, 4, 5, or 6. What possible numbers of cases are the opposite of 1, 2, 3, 4, 5, or 6? Just 0. So this number is a 0. And since this number is 0, it doesn't really make sense for this to be a less than or equal to sign, because you can't have less than 0 cases solved. So you could actually turn this into an equal sign for this particular case. Okay? If this were any other number, that would have stayed a less than or equal to sign. So this is what we need. All right. Now what? We need to find out what this is so that we can calculate the complement, 1 minus that. How do we find this? You might be screaming right now at your phone or your computer. We already know this. This is what we just found, right? Probability that x is 0. Okay? I told you. Some problems are going to be like this, where they're going to ask you to calculate a probability, and then one of the parts later down is going to ask you a question that involves that same probability you just found. Don't reinvent the wheel. Don't calculate this again. You already know it. It's 0.262. This is 0.738. 0.738? Yeah. Okay. So, what this is saying is, there's a 26.2% chance that none of the cases get solved. But that leaves a 73.8% chance that at least one will be solved. Those events are complements of each other. It would have been even better if you noticed that these two things were complements of each other right away. If you had just read parts A and B and then noticed that B was the complement of A. I'm not expecting you to know that right off the top of your head, but it would save you a lot of time to know that. C. Part C. What is the expected number of crimes that will be solved, and what is the standard deviation? Okay. These are reviewed from prior videos, but part C, you need to pay attention over here to figure that one out. We need to calculate the mean and standard deviation here. So, the mean, the formula for that is just n times p. Actually, this was also in a prior video, so I guess this wasn't really necessary here. Oh well. The mean is n times p, and we already know what both of those are. That's why I usually write them down at some point. They usually come in handy. So this is going to be 6 times 0.2. That's 1.2. Yeah. And the standard deviation is the square root of npq. Q is also sometimes written as 1 minus p, because that's what Q is. I could write that here. That's going to be 0.8. And if you wrote this out here, you already know what Q is. So we just need to take the square root of 6 times 0.2 times 0.8. And that is going to be something I do not know off the top of my head. 0.98. 0.98. So, what these parameters tell us is, in those 6 cases, we can calculate the probability they don't solve any of them. We can use that to figure out the probability that they solve at least one. But we also know how many of those 6 cases we expect them to solve on average, 1.2. And the standard deviation tells us how variable that is if we were to do it over and over and over again. Okay. So you can already start thinking, the problem isn't asking anything about this, but you can use these numbers to figure out what would be an unusually high or low number of cases for them to solve out of these 6. If you subtracted 2 standard deviations from the mean, you're going negative. So it's not particularly surprising if they don't get any of the cases solved. if you were to add 2 standard deviations, that would be adding about 2 to this. That'd be like 3.1 something. So that would say that anything up to about 3 cases solved out of 6 is not unusually high. But if somehow they solved like 5 or 6 of those 6 cases, that would be kind of weird. That's a much higher value than we would have expected given this. Okay. There is a part D to number 23, but it is, does it say it? Yeah, it calls it a quota problem, and that would take its own video to describe how that works. So unfortunately for you guys this semester, you're not going to get to the quota problem. And to be honest with you, in a normal semester, we usually actually get through chapter 6. And due to the lower number of e-learning days, you essentially have been cheated out of an entire chapter. But I hope that through all the videos in this section, you feel comfortable. You can now tackle the homework problems that you'll be getting for this section. You can expect to see a Chapter 5 review of the topics that you'll need for the Chapter 5 test that you will take on the last e-learning day. For you seniors, it's your last e-learning day. That's May 29th or 28th, something like that. I don't know. I have to look. Okay, so you'll have homework for this section, you'll get the Chapter 5 review, and you'll take the Chapter 5 test. There will be no final exam. That Chapter 5 test will be the last thing that you do for this class. As always, if you have questions over this stuff, it's not the easiest stuff in the world. If you have a question, shoot me an email. Super happy to help out. Lots of times I just sit at my desk hoping somebody asks me a question so I can help them out. It's why I got into teaching. So ask me a question. Okay. That's it. So you may see another video from me in the future that's not related to statistics material, but in terms of learning new stuff, this is it for the year. So I appreciate you guys watching these videos. If you made it this far, I'm proud of you. It is not easy doing education this way. It's not how I would have wanted to do it. I apologize that you got this short end of the stick this semester, but we'll get through it. So enjoy, and we'll see you for maybe one last video at the end of the year. Have a good one.